Hello students, welcome to my YouTube channel and welcome to the topic of matrices. In this particular video session, just we are going to discuss about the elementary transformation, or you can say that elementary operation method. It is of three types. Total, there are three types of different types of operations, and we are going to discuss about the first one. The first one is the interchange of any two rows or columns, and it is denoted by two symbols, either by using the row interchange or by using the column interchange. The elementary operations of interchange of ith row and jth column is denoted by Ri interchanged with Rj. Similarly, the elementary operations of interchange of ith column and jth column is denoted by Ci interchanged with Cj. Then let us go through another example, one of the example based upon the first type of operations. So here it is the example based upon the first operation of elementary transformation method. It is given that A matrix is 1, 2, 3, 5, 4, 6, 2, 8, 5. On applying R1 interchanged with R2, that means interchanging row 1 and row 2, we are getting a new matrix here, and that is taken as B, and that is 5, 4, 6, 1, 2, 3, because row 2 got replaced to row 1 and row 1 got replaced to the position of row 2. So the matrix B will be a new matrix and it will be 5, 4, 6, 1, 2, 3, 2, 8, 5. And it is the example of interchange of rows. And you can also consider another example in which you can interchange two columns, and it is the task up to you. Then let us go through the type 2 operation. So here it is the type 2 operation of elementary transformation, and it is the multiplication of the elements of any row or any column by a non-zero number. That means you have to multiply a non-zero number to all the elements present in the given row or the given particular column. And symbolically it can also be represented by two ways, as like this type 1. And the first one is the elementary operation of multiplication of the element of the ith row by a non-zero number k. That is, the given number is k, and you have to multiply that k to all the elements present in the given row, particular row. And suppose that particular row is Ri, then you have to multiply the number to all the elements of present in the row Ri, and then you have to write down again in the form of a new. Similarly, in case of column also, and you have to multiply the non-zero number k to each and every element present in the particular column, and you have to mention it in the form of Ci is replaced by Kci. In case of row, we have written Ri is replaced with Kri. But here in case of a column, we have to write down Ci is replaced by Kci, and k is the non-zero number. And you have to multiply that k to each and every element present in the particular row or particular column mentioned to you. Okay, then let us take an example based upon this type 2 operation. So here it is the example based upon the type 2 operation. Let us consider a matrix A is equal to 1, 4, 5, 6, 7, 3, 4, 2, 7. Suppose we have to replace one particular row or one particular column, and here we have taken the particular row, and that row is row 1. And we have to replace that row 1 by multiplying a non-zero number 2 to each and every element present in that particular row. That means consider the elements, and these elements are 1, 4, 5. Then you have to multiply the non-zero number 2 to each and every element present in the first row. It is given that you have to replace the row 1 by 2R1. That means you have to multiply 2 to each and every element present in the row 1, and then you have to write down the obtained values in the place of a row 1, and the row 2 elements and row 3 elements will be unchanged. That means 6, 7, 3, here you can see that 6, 7, 3, 4, 2, 7, 4, 2, 7, because it is given that you have to replace the row 1 only, not row 2, not row 3. That means row 2 and row 3 will be unchanged, and you have to replace, or you have to change the row 1 by using this formula 2 row 1. That means you have to multiply 2 to each and every element present in the row 1. That means the row 1 will be changed only, and it will be replaced by the elements 2 1s are 2, 2 4s are 8, 2 5s are 10. These 3 elements are changed and the rest of the 6 elements are unchanged. So it is all about the type 2 operation, and we have considered the row only. You can consider another example by considering column also, and it is up to you, and you can consider any of the example, and then you have to consider or you have to change any of the column by multiplying a non-zero number to each and every element present in that particular column, and then you can get or you will get a new matrix from the given matrix. Then let us go through the type 3 operation. So here it is the type 3 of elementary transformation method. The addition to the elements of any row or column, the corresponding elements of any other row or column multiplied by a non-zero number. Let us explain this. Suppose there is a given matrix. There are 9 elements present in the matrix A. Suppose you have to change the row 1 by using the help of the row 2. By using the help of the row 2 elements. That means total you have to consider 6 elements. But you have to change the row 1 or you have to change you have to replace the row 1 elements. So first of all you have to multiply a non-zero number k to each and every element. K will be multiplied to each and every element present in the row 2, and then you have to sum or you have to get the addition of the corresponding elements of the 2 rows, row 1 and row 2. That means you have to replace row 1 as row 1 plus k row 2. So it is the procedure. That means you have to replace the row 1 by using the help of the elements of present in the row 2, but the procedure is that first of all you have to multiply a non-zero number k to each and every element present in the row 2. Then you have to add the corresponding elements of row 1 with the corresponding elements of row 2. So it is all about the type 3 operation of transformation method. Let us take an example based upon this. Again, this type 3 operation have 2 cases. The first one is row case, and similarly there is a column case. If you are replacing a row, then it is denoted by Ri is replaced as Ri plus K Rj, because Ri and Rj are 2 different rows of the given matrix. Similarly, if you are replacing a column by using the help of another column, then it is denoted by Ci is replaced by Ci plus Kcj. And let us take an example based upon this type 3 operation. So here it is the example based upon the type 3 operation. And here we are replacing the row 1. That means we are replacing 2, 3, 4. These 3 elements will be replaced, and the rest of the 6 elements will be unchanged. You can see that 5, 6, 7, 1, 5, 3, 5, 6, 7, 1, 5, 3. Only row 1 will be replaced by using the help of a row 2. By using the help of a row 2. How it is replaced? It is given that the condition is that the corresponding elements of row 1 will be added to the corresponding elements of row 2 multiplied by a 2. That means the row 1 elements are 2, 3, 4. Then you have to multiply a 2 to the each and every element present in row 2. That means 2 5s are 10, 2 6s are 12, 2 7s are 14. Then you have to add the corresponding elements. This is 12, this is 15, this is 18. And these 3 new numbers will be there in place of row 1. That means these 3 numbers will replace the first original 3 numbers present in the row 1. That means 2, 3, 4 will be replaced by 12, 15 and 18. And it is a new matrix. So it is named in a new format, and that is named as B. So here it is all about the type 3 operation method of the transformation, elementary transformation or elementary operation method of the topic matrices. So then finally you will get three important notes from the elementary transformation method. The first one is that clearly there are three types but total 6 cases, because one type, any of the type contains two cases. One is the row case, another is the column case. So clearly there are three types, total 6 cases of elementary transformation or operations can be used for a matrix. 3 of them are used for rows, they are called as row operations. Rest 3 of them are used for columns and they are called as column operations. So these are the 3 important notes based upon the elementary transformation method. Now let us go through the equivalent matrices. Now let us discuss about the equivalent matrices. Two matrices A and B are said to be equivalent matrices if one can be obtained from the another by applying finite number of elementary operations on the other matrix. That means suppose there are two matrices A and B and you have to apply a finite number of 2, 3, 4, that means countable number of elementary transformation methods on the matrix B, and then you will get the matrix A. Suppose it is a given matrix B, then you are applying some of the elementary transformation methods here. Then after some of the steps you will get a new matrix and that is B. So then you can call these two matrices A and B as the equivalent matrices, and it can be denoted by the symbol A equivalent to B. Let us discuss about an example based upon the equivalent matrices. So here is the example based upon the equivalent matrices. It is given that there is a matrix A and a matrix B of order 3 and you have to show that A is equivalent to B. So let us consider the matrix A. First of all, apply a elementary transformation method, and that is applying the condition C2 is interchanged with C3. That means position of the elements of C2 and the position of the elements of C3 are interchanged. That means we are getting a new matrix here. This is 1, 5, 6, 1, 5, 6. Column 1 is unchanged, but we are interchanging column 2 with column 3. That means 4, 2, 8 will be in the position of row 2 and 2, 4, 7 will be in the position of C3. It is in the position of C2, it will be in the C3. Then applying another elementary transformation method here, C3 is replaced by 3C3. That means you have to write down the elements of C3 by multiplying a 3 here. Each and every element will be multiplied by 3. So you can consider C3 will be changed, but C1 and C2 are not changed. So first of all, we have to write down C1 and C2. You can see that 1, 5, 6, here is 1, 5, 6, C2 is 4, 2, 8, 4, 2, 8. But only you have to change the elements of C3 by multiplying a non-zero number 3. So 3 2s are 6, 3 4s are 12, 3 7s are 21. And you can see that this is the matrix B given in the question. So we have applied two elementary transformation methods on the matrix A and we are getting here the matrix B. So after a finite number of steps, or you can say that after two elementary transformation methods, we are getting B matrix from the matrix A. So A and B are equivalent matrices. So A and B are equivalent matrices, and here it is the proof. So at last we are going through the last step here of this video session, and that is elementary matrix. A matrix obtained from a unity matrix by a single elementary operation is called as elementary matrix. Suppose we have considered an unity matrix of order 3 1 0 0 0 1 0 1 0 0 0 1. According to the definition, we have to apply a single elementary operation. Only one operation will be applied here. Suppose that is row 2 is replaced by 2 row 2. That means row 1 and row 3 are not changed, only the elements of row 2 are changed. So you will get a new matrix. We will get a new matrix, and that will be 1 0 0. The elements of the second row will be multiplied by 2, so it will be 0 2 0 0 0 1, and you can see that it is a new matrix and it is called as the elementary matrix because it has been derived from the unit matrix by a single elementary operation, not more than one, only one operation. So it is elementary matrix. So in this particular video session, just we have discussed about the elementary transformation or operation. Then we have discussed each and every type of elementary operation by using an example. Then we have discussed about equivalent matrices, and then we have discussed about the elementary matrix. In the next video session, just we are going to discuss about some of the more problems based upon this concept. Till then, thank you.